Python has become the undisputed champion of data science. Its powerful combination of simplicity, vast libraries, and strong community support makes it the go-to language for everything from data analysis and visualization to complex machine learning and deep learning applications. Let's break down the essential libraries you'll encounter in the data science ecosystem, categorized by their typical use. These are the bedrock libraries that form the base for almost all data science work in Python. You absolutely start here to build a strong foundation. NumPy is the fundamental package for scientific computing in Python. It provides highly efficient n-dimensional array objects and a vast collection of functions for performing mathematical operations on these arrays, making it incredibly fast for numerical tasks. Built on top of NumPy, Pandas introduces two powerful data structures: series, 1D labeled array, and data frame, 2D labeled table. It's the go-to library for data manipulation, analysis, and cleaning. If you're working with tabular data, Pandas is indispensable. Matplotlib is the foundational plotting library in Python. It allows you to create a wide variety of static, interactive, and animated visualizations, from simple line plots to complex 3D graphs. It forms the basis for many other higher-level plotting libraries. Once you're comfortable with basic data handling and visualization, you'll want to move to tools that help you create even cleaner visuals and perform more sophisticated statistical analysis. Seaborn Library builds on Matplotlib and provides a high-level interface for drawing attractive and informative statistical graphics. It simplifies the creation of complex plots like heat maps, violin plots, and pair plots, which are crucial for exploratory data analysis. Stats Models is a Python library for exploring data, estimating statistical models, and performing statistical tests. It's used for tasks like linear regression, time series analysis, and hypothesis testing, providing statistical insights into your data. After mastering data manipulation and visualization, the next step is typically machine learning, building models that can learn from data and make predictions. Scikit-learn is the most popular and comprehensive machine learning library in Python. It offers a unified interface for a wide range of supervised and unsupervised learning algorithms, including classification, regression, clustering, dimensionality reduction, and model selection. It's incredibly well documented and easy to use. XGBoost and LightGBM are highly optimized open source gradient boosting libraries. They're renowned for their speed, performance, and accuracy in competitive machine learning tasks and often outperform traditional algorithms on structured data. They're critical tools for building robust predictive models. If you're interested in the cutting edge of AI, specifically deep learning and building neural networks, these powerful frameworks are where you'll spend your time. Developed by Google, TensorFlow is an end-to-end open-source platform for machine learning. Keras is a high-level API that runs on top of TensorFlow and other backends, making it much easier to define, train, and evaluate deep neural networks with minimal code. It's great for both beginners and researchers. Another leading open-source machine learning framework developed by Facebook's AI Research Lab. PyTorch is known for its flexibility, dynamic computation graph, and Pythonic interface, which often makes it favored by researchers for its ease of prototyping and experimentation with complex models. The field of data science with Python is incredibly dynamic and rewarding. To delve deeper into any of these areas, you can refer to comprehensive resources and tutorials on Python for data science.